kick things off, Sam, could you tell us a bit more about why nutrients matter so much for a good corn crop?
Absolutely, Joel. One of the hot topics in agriculture today is nutrient use efficiency. And two questions come to mind as to why that's important. The first question is we need to do a better job of utilizing our nutrients in the soil as those that we derive from other sources. The reason is these nutrients are so vital for plant growth, development, and for yields. The second thing that's really critical for nutrient use management, and one reason so many people are talking about it, is done right, we can impact the environment. So we can decrease the amount of loading in the environment as well as in creating better sustainability for us in future generations. So really what this slide shows is the average corn grower in the Midwest might be targeting plus or minus 230 bushels. We know that the average U.S. corn yield is 170 bushels to the acre. But what this slide shows is 3 macronutrients and 3 micronutrients that are really important to corn growth and development. We know that there's 17 different nutrients that are essential for corn growth and development. Hydrogen, carbon, and oxygen would account for 95% of the total dry matter that's responsible for plant growth and development. And we get these 3 from the air and from the water. But the other 14 essential nutrients, many of them are on this chart right here, like nitrogen, phosphorus, potassium, sulfur, and zinc, are also very, very important to plant growth, even though they only make up about 5% of the total dry matter for the plant. So as we look at this graph, I want to kind of focus your eyes on column number 1. Basically for nitrogen, if you look at column number 2, we need for 230 bushel target yield, we need 256 pounds. For phosphorus, we need about 100 pounds. And for potassium, we need about 180 pounds. So this gives us a rough average of how much N, P, and K is required to produce a corn crop. And we also see the micronutrients like zinc, sulfur, and boron are also used. Columns 3, 4, and 5 show you different production coefficients or indexes that we also use. For example, column 3 basically shows that on a pound per bushel, we're harvesting about 1.1 pounds of nitrogen, about a half a pound of phosphorus, for example. So we get about, of all the nitrogen required in the plant, about 60% of the nitrogen that we need ends up in the kernel or in the removal by the crop. So what this slide shows, and it's really one of the biggest dilemmas that we have in agriculture and why we talk so much about nutrient use deficiencies. When we look at the soil, the soil has 4 basic components: the pore space, which is 25%, the water space, which is 25%, the mineral fraction, which is about 45%, and probably one of the most important fractions is the organic matter, which is about 5% on average. Particular soil that we have below here is actually a typical soil for Illinois, and this actually was some data derived from the University of Illinois. This soil has a 3% organic matter. And what you see immediately from this slide, if you look at line number 1 with nitrogen, that in an acre for a slice of soil, which is equivalent to 2 million pounds of soil, we have a lot of potential nitrogen, phosphorus, and potassium that's simply unavailable. In fact, if you look in column number 2, you see that the total amount of nitrogen in pounds per acre that's available is over 4,000 pounds, which is a big number. Same is true with phosphorus. We have about 1,200 pounds. If you look in column number 3, basically you see the different forms of nitrogen that are available, which is nitrate and also ammonium. And of course, we have phosphorus in the soil as well. But what is very interesting about this slide and the real dilemma that we have in agriculture, particularly during certain parts of the growing season when we need so much nitrogen and phosphorus readily available. If you look in column number 4, the amount available and the form that it's in, we have only 1 to 50 pounds of nitrogen available. This is why nitrogen is one of the biggest challenges for us in producing a corn crop, because many times, even though there's a lot of nitrogen in the soil, the plant available nitrogen can be very limited. The story is true also with phosphorus. Phosphorus has to be in soil solution, and only a small portion of that is in soil solution at any one point in time. And you see in column number 4 for phosphorus, we can have as little as 1/10 of a pound per acre of nitrogen available when the plant is really trying to pull in a lot of N, P, and K at this point in time. That is a real challenge for us. We lose a lot of our nitrogen anyway through volatility, leaching, and denitrification. So anything we can do to make more nitrogen available is going to help the grower. The same is true with phosphorus. From the time that we put a phosphorus fertilizer out to the time that we try to harvest it at the end of the year, a lot of the phosphorus is tied up by iron and aluminum complexes and is simply not available in the plant. So when you see a number like you see in this graph here of 4,000 pounds to the acre and only 1 to 50 pounds are available, you can see that a lot of complexes are going on with nitrogen and losses, as well as with phosphorus and the losses that we occur.